Hello, in this video we're just going to solve one problem. We're going to use limits to find the derivative of f of x equals 4 minus x squared. Another way to say that is we are going to use the limit definition to find the derivative of that function. Now the limit definition, it's a formula that you should have memorized, and it is the limit as change of x approaches 0 of f of x plus change of x minus f of x divided by change of x. That's the general formula for it. Now, I'm going to go into a little bit of explanation of that, just a slight one. So if you want to jump ahead to the solving, feel free to skip a couple minutes in the video. Now, when you see use limits to find the derivative, you need to associate derivative with slope. So that's really finding the slope of this function, finding a function that describes the slope of that function. And you know that slope is rise over run, y2 minus y1 over x2 minus x1, which another way to write that is change of y over change of x, kind of fancy way to write it. So that's why we have in our denominator here a change of x, so that's standing for the change in the x terms. But then up top, this is referring to the change of y. Okay, so if my first point is at x and I have my curve, and I move over a certain change of x, I can just relabel this point x plus change of x. And then my y values, well, the first one, f of x, because you just plug in x into the function, and then the second one would be f of x plus change of x. And so, of course, to find the difference between these points, you would just subtract them. So when I say that change of y is the same as f of x plus change of x minus f of x, we can see why. Of course, when I'm finding that slope, see, it would be the slope between those 2 points. That's what we call the secant line. It's between 2 points. But we don't want that. We want the slope of the tangent line at just 1 point. So we want to bring our second x value closer and closer to x. We want it closer and closer and closer and closer. In fact, how close do we want it? We want there to be no change of x at all. We want that to go to 0. Hence, we have the limit as change of x approaches 0. And that's sort of our reasoning to set up this function. The change of y divided by change of x, it's just change of y, is fancy as f of x plus change of x minus f of x. And then we got to take the limit as change of x goes to 0. So that in fact we are finding the slope at a single point, okay, at what we call the tangent point. Okay, so now that's the general function, but we have to apply it to our specific one, f of x equals 4 minus x squared. So that's f of x. Then I like to build it. So I put in f of x plus change of x. See, I'm slowly going to build this. I found f of x. Now I'm going to do x plus change of x. So that's just taking our function and plugging x plus change of x in for every x. And then I can simplify that a little bit. Minus x plus change of x times x plus change of x. So we gotta do some distribution. 4 minus x squared plus x change of x for that. And then right here we got another x change of x. And then finally a change of x squared. Simplify, it's 4 minus x squared plus 2x change of x plus change of x squared. And the last thing I can do is then distribute this negative to each term, giving me 4 minus x squared minus 2x change of x minus change of x squared. So that is my f of x plus change of x. Okay, I haven't done any derivative work or anything yet, but now I'm going to take each of those pieces, f of x and the x plus change of x, and put them together in my limit function. That gives me the limit as change of x approaches 0 of 4 minus x squared minus 2x change of x minus change of x squared. And then I subtract f of x, which is 4 minus x squared. Put it in parentheses because you're going to have to distribute that negative. And on the bottom is just change of x. When you're doing the limit definition of the derivative, change of x is always there in the denominator. Alright, so what do I notice here? How can I simplify the top? Well, this 4 cancels with this 4, because when you distribute the negative, that becomes negative 4. Also, when I distribute the negative, it's now plus x squared, so plus 1x squared minus 1x squared, they're gone. Leaving me with just negative 2x change of x minus change of x squared, all divided by change of x. When we're doing the limit definition, this is what we want. We want all of the terms without a change of x to disappear. And that tends to happen when you do it. It means you can find a derivative. And so that happened to us because now we split this apart. That change of x divides both of them. So I have 2x change of x divided by change of x minus change of x squared over change of x. And you can notice that we get some reducing, which is awesome. Cancel one of those. So I have negative 2x minus change of x. This is why we wanted all terms without a change of x to disappear. Because then the change of x in the bottom will cancel with everything up top, taking away that denominator. See, that was the issue, because if I did the direct substitution, I would have gotten a 0 in the denominator. Can't do that. Okay, but now with this reduction, I got rid of the denominator, so now I can take the limit, and what happens? Change of x goes to 0. This is unaffected, leaving me just negative 2x as my derivative. So after doing the limit definition, I can confidently say f prime of x is equal to negative 2x. So this problem asks to use limits to find the derivative of f of x equals 4 minus x squared. But another way it could have been worded is to use the limit definition to find the derivative of, and then here's our process for it.